Welcome you all my dear students. In last video we discussed about introduction about shear force and bending moment, and we very important things what you should know from previous video is the first thing is that definition of shear force, that is the summation of algebraic sum of all the vertical forces either left side or right side of the section, and bending moment, it is the algebraic sum of all the moments either left side or right side of the section. Then after that, very important thing you should know is where to take the sections. For shear force, whenever a point load is acting, you have to take two sections, one just left of the section, left of the point load and right of the point load. And whenever you are dealing with the bending moment, you have to take two sections, one just left of the moment and another just right of the moment. These two rules you have to remember. Then after that, you have to remember sign conventions. For support reactions, upward positive, downward negative, rightward positive and leftward negative. This you have to remember. And for shear force, this symbol means if you are looking at the right side, then downward is positive. If you are looking at left side, then it is upward is positive. Then shear force, if you are looking at right side, upward is negative. Then if you are looking at left side, downward is negative. You can remember two words, that is a run means right up negative, loop means left up positive. These two you can remember. The other will be just opposite to this one. Then bending moment sign conventions you have to remember, that is sagging is a positive and hogging is a negative, or otherwise you can remember those bodyguards who are showing their body by lifting their arms. Means when you are solving the problems, if your arms are lifting because of the force, then that is a positive. And some bodyguards, they will show their arms by this way, you know, the like this one hogging, you know. Here if your hands are coming down when you are dealing with the problem, then that is a negative, right? Now we will go one by one for cantilever only. This video will cover only cantilever problems. And after this you should it is also discussed that what all steps involved, procedure to draw SFD and BMD, right? Procedure to draw SFD and BMD. First one is what? We have to draw the free body diagram. Why we have to draw the free body diagram? Because we want to determine support reactions. First procedure is draw free body diagram, draw FBD. Second one is uh, determine support reactions. Determine support reactions. Okay. Third one is write SFD, shear force you determine, and after that you will determine BMD. Okay. Then after this one you can draw a diagram. Draw diagram. Correct? Okay. This is a exact procedure for any beam, either it is a cantilever or simply supported overhanging, whatever it is. That is a common. But very careful. Now we are dealing with the cantilever problems. Therefore, no need to follow these two steps. No need to follow these two steps. Why? Because our cantilever is something like this. Something like this, right? You will be having some loads here and there. Okay. See here, support reactions means what? Here support reactions are here, one support reaction, the another support reaction, and another support reaction. And what do you mean by sections? Sections means you will take one section here, point load is there, therefore one section here, one section here, here one section for shear force, bending moment also one section here, one section and section, whatever it is you are considering. And you have an option of seeing observing either right side or left side of the section. You have an option. This observation is the option left to you people. That's why what I make one conclusion for cantilever beam is I always look towards the free end. I always observe towards free end. When I observe only free end side, means when I take this section, observe free end side. 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 When you are observing every time a free end side, means you can ignore the support reaction because support reactions are in right side, the other side. Therefore, no need to find support reactions. These are no use in a cantilever beam. This you have to remember. That's why while dealing with the cantilever beams, we are ignoring drawing shear force diagram and determining support reactions to minimize the problem solving time. Understood? This we have to remember. Now, first, these are all just 2 marks or 3 marks questions. Now, what we are dealing here is this is a cantilever means these type of problems are something like a derivation because here numerical values they may not give, so that you are making some standard beams, you are considering standard loads and standard beam, and you are naming them. Length means L and load means W, like that you will be naming, and after that you will solve the problem. You will draw SFD and BMD for these standard beams, right? And after this you can by heart those values. Whenever the numerical problems will be given on these such standard beams, you can just by heart these values and you can write it, okay, in later. Now we will deal, that's why I will be very fast when I am dealing with this standard beams, right? I will be very fast, and later when I come with the combination of various loads with the cantilever, there I will go very slowly, right? Right. Now this problem is given in a statement, we have to draw. This problem is given in statement, we have to draw a diagram for this one. Cantilever carrying moment at its free end. Now look at here, this is your cantilever and length of the cantilever is L. Length of the cantilever is L, and what they said is it is carrying a moment at its free end. Means let us consider this is a moment. Okay, this is a moment name M. Okay, now why I consider this clockwise, that is left to you, because it is just like a derivation type. I can consider clockwise or you can consider anti-clockwise, whatever it is, just we have named here. Then after that we should know here two types of beams are there, or 2 points are there, we will name them. This point I will call it as a point, and this point I will call it as a B point. A and B points are there. Okay, now always remember, whenever you are dealing with a cantilever, come from left side. Sorry, a free end, come from free end. Here free end is right side, therefore we will deal everything with respect to that right side. Okay, now I will write what will do in your notebook or otherwise in your paper, you make this space blank. Okay, this complete place will be just for shear force and bending moment diagram. Everything whatever we write, we will write it in the right part of the page. Okay, now we will come from point B and then we'll go to point A, because always we will follow in cantilever moving from free end to the fixed end. Okay. Now point B is there. Now I am writing shear force. Shear force at B I can write. Why? Because at B there is no point load, that is a moment. Therefore I am writing at B. Now shear force at B means I will put a section at B. Then after putting this one, observations, what you do? Observation, I will see right side. Observations right side. When you see right side, what is there? Beam has ended up. No, at B point it is ended. Therefore, you don't have anything in the right side. Therefore, the answer will be 0. Shear force is 0. Now coming to the another point, then shear force at A. Now shear force at A means at this point. Okay, shear force at this point. Take a section at A. Take a section at A. But observation, make observation right side only. Make observation right side only. Okay, take this point and see this side. What forces you are seeing? How many forces are there here? No vertical forces. Shear force definition, it says that summation of vertical forces. No vertical forces here. Therefore, this is also 0. Now over A point and B point both are determined. Therefore, I can draw now shear force diagram. Diagram will be just I will mark one horizontal line. Okay. And what is the shear force at B point? 0. What is the shear force at 8.0? Therefore, you will not get any diagram for SFD. Over. Right? Now we have understood the SFD for this beam. Now we'll go for BMD. For BMD, then the same procedure I will follow for bending moment. Okay. First point, bending moment at at. Now be careful. What is the rule for bending moment? Bending moment rule is whenever there is whenever there is a moment, you have to take two sections. Now the moment is acting at this point, right? But you have to take two sections. One just left and another just right. Right? Two sections I have to consider. Right? Now, first we will deal with one. The first one I will consider right of the section. Right of the section. Okay. Bending moment at right of moment, not section, right of the moment. Right of the moment. But what about observation? Observation, you observe right side. Okay. When you observe right side, what you are seeing? Nothing is there because beam has ended there. Therefore, the answer is 0. Right? Next question, next point. Next point is bending moment, bending moment at left of left of moment, left of moment. Okay, left of moment means this point. When you consider that one, then observation. Where you want to observe? The observation I will make again right side only. Again right side. When I make observation right side, I am seeing one moment here. That moment look like this one. This one means it is a negative. Therefore, it is negative m. Instead of only one moment is there. Over. Now I will come to bending moment at A. Here I am ignoring moment or support reactions here. That's why I am directly taking at A. Don't worry. Okay. Bending moment at A. When I go to bending moment at A, I will take a section here. Then what about observation? The observation where I will do? I will do observation right side. When I do observation right side, what all things you are seeing? What all moments? Only one moment is there, no? That M. And the direction of M moment is matching with this direction. Therefore, that is minus over. Bending moment diagram is over. Now here I will draw one A point and this is the B point. I will join these two. Then at B point I have a negative M. Negative M. At A point I have a negative M. Therefore, I will join these two. This is a negative bending moment diagram BMD. Okay, for cantilever carrying moment at its free end. Right? We will go to the next problem. The second problem is cantilever carrying point load at its free end. Now look at it. This is a point load. Point load, I will call it as a P. P is a point load. Then length is L. Length is L. Okay. Now we will keep this space for diagram. Then we'll come here. First we will write a shear force. Shear forces. This point we'll call it as A and this point B. Now start with the point B. Shear force at okay B. B point we have a point load. Therefore we have to take two sections. Remember point load two section for shear force. Therefore one just right of the right of B. Shear force at right of B. Okay. What about observation? We will make observation right side. From this section right side you see nothing, therefore that is 0. Next, shear force at left of B. Left of B means you stand here, this is your section. When you are observing this section, when you are observing this section, then observation you make it right side. Observation right side. What you are seeing? You are seeing one vertical force. That vertical force name is P. What is the direction of that one? Okay, right side you are observing. Okay, right side means this is the right side. Right side you are observing, and right side downward indicating positive value. Therefore, this is a positive P. Over. Next, coming to shear force. Shear force at A. Okay, take a section at A. When you take a section at A, then observe. Observation you make it on right side. Observation is right side. What you are seeing? You are seeing again only one force. That force is P. What is the direction of that force? Direction is matching with this force. Therefore, that is positive P. Over. Shear force is over. Now we'll draw a shear force diagram. We'll consider this point A and point B. Horizontal line. At A point, first it is 0 and the second it is P. Both are at same point. Therefore, I'll draw one point here P, positive P. Then after that, this is also P. This is a positive P. Then I will join these two. This is a positive value and this is SFD. Okay. Now coming to bending moment diagram. Bending moment diagram, BMD. BMD, for that BM, first point I will consider BM at A. Why BM at A? Because there is no moment. Directly I can consider a force here. Right? Now bending moment at B point. Sorry, this is B point. No, bending moment at B point. When I consider B point, then where you want to observe? Observations you make it right side. What you are seeing right side? Nothing. 0. Therefore over. Then bending moment at A point. At A point means this one. Then observations where you want to make. This is also right side. Observations where you want to make. Observations will make right side. Therefore right side. What you are seeing? Okay. At this point, right on. At this point you are seeing one moment here. The moment is force P into perpendicular distance. This is a perpendicular distance. Therefore you are seeing P into L. This P into L perpendicular distance, that is creating a moment in this direction. This direction is matching with this force, this direction. Therefore, it is negative. Right? Minus PL is the bending moment at A. Now we'll draw the diagram. This is point A. This is point B. Draw one reference horizontal line. Then after that, at this point, bending moment at A is 0. Therefore, it is 0. Then at B is 0. Then after that, bending moment at A is minus PL. Therefore, this is P into L. Then, wherever there is no load, in last class we have discussed. Right? I'll show you that. You can see between 2 point loads. Between 2 point loads, the bending moment variation is linear. Bending moment variation is linear means I have to draw one linear line like this. Okay, this is your negative bending moment diagram, BMD. Right? Now we'll go to the third problem. Now look at here. Cantilever beam carrying point load at its middle span. Middle span. Now we'll draw the diagram for this beam. Okay, this is a cantilever of length L. Then I have a middle point here. At this point you have a point load. This point load will call P again. Right? Then what is this distance? This is L by 2. This is L by 2. Then we'll name these points. This is A. This is B. This is C. Right? Now we'll leave this space for diagram. Then we'll go on writing the right side. Now the shear force, no, shear force at C. C nothing is there, therefore I can consider only one section at C. Then at C is there, then take a section here. This is a section where you want to observe. The observations I will make right side. Right side what you are seeing here. You are seeing nothing, therefore 0. Then shear force at at B. Okay, at B, be careful. We are dealing with a shear force. Therefore, shear force when you are dealing with the B point, then you have to take two sections. Therefore, I will take at right of right of B. Right of B means this is my section. This is my section. Where you want to observe. The observations we will make right side. What you are seeing? I am seeing nothing. Over. This is the right side. Okay. Then shear force at left of B. Where is left of B? I'll show you. This is a left of B. If this is a left of B, then observations where you want to make. Observations I'll make right side. Okay. When you are seeing when you are making observations right side, then what you are seeing? I am seeing one vertical force. Only one vertical force? Yes. One vertical force, its name is P. Then whether this vertical force is negative or positive. This is right side coming to here, right side downward is this one, and therefore that symbol is matching with this arrow, that is positive. Therefore this is positive P. Then over, that is. Then shear force at A. Shear force at A, then observations where you want to make. I will take this as a section. You delete this section, over it is. Okay. Now I will take this as a section. Where you want to observe? I want to observe right side. I want to observe right side. Then what you are seeing right side? I am seeing only one vertical force. That name is P. Okay, that vertical force is positive or negative? That is positive because that is matching with this positive. Over. Shear force at C and B and A is over. Now I will draw shear force diagram. A horizontal reference line. At this point, what is shear force? 0. At this point, two shear force. One is 0 and another one is positive P. Let us consider this is positive P. Then at this point, positive P. Therefore, this is my shear force diagram. This is positive, this is SFD. Over. Okay. Now we'll come to BMD. We'll come to BMD. BMD, for that I will write here. Okay. First point, bending moment at C point. Okay. Bending moment at C point we are taking. Okay, this is your section. Okay, observations will make right side. What you are seeing right side? Nothing. Therefore 0. Then over. Bending moment at B point. Take a section at B point. Observe at right side. Observe right side. What you are seeing? Again nothing I am seeing. Now bending moment at A point. Okay. Bending moment at A point. What you are seeing? Observation. We will make right side. What you are seeing right side? I am seeing right side one moment. What moment you are seeing? That moment is P into L by 2, because at this point I want moment P into L by 2. P into L by 2. Whether it is positive or negative. Okay. This moment is rotating like this at this point. About this point it's rotating like this. This is matching with this symbol. Therefore that is negative. Okay. Over. Now I will draw shear force bending moment diagram. A horizontal reference line. What is the bending moment at C point? 0. What is the bending moment at B point? 0. What is the bending moment at A point? Minus PL by 2. This one. Okay. When there is no load, then I have to draw straight line. Oh, this is a negative bending moment, BMD. Data. Next problem. Next, cantilever carrying UDL throughout the beam. Now look at here. This is cantilever carrying UDL throughout the beam. And what is the load intensity? This intensity I will call it as a W kilonewton per meter. Okay. Now draw free body diagram for this UDL. UDL I will convert it into point load, but this conversion is for my reference. Be careful, this conversion is for my reference, not given one. Therefore, I am writing this conversion dotted line. This conversion is W into the length of the beam is L. Therefore, WL is a conversion of UDL to point load. Then where this point load is will be acting, that will be acting L by 2 distance, at a distance L by 2. Okay. Now we will name these points. Okay, one point is A and another point is B. That's it. Okay, don't mark this as a C point because that is your reference. No, there is no point there. A and B is enough. Now we will write a shear force diagrams. Okay, the first one, shear force at B. I can take at B because there is no point load. Okay, at B. Okay, this is a point. Then observations where you want to make. Observations you want to make right side. Okay, right side what you are seeing? Nothing you are seeing. 0. Over. Then shear force at A. You can make at A like that. Then at A means this one. Okay. Where you want to observe? The observations I want to make right side. Right side what all vertical forces you are seeing? You are seeing vertical force. Yes, one vertical force you are seeing. That is your W into L. What is the direction of this vertical force? Downward. Right side downward. It look like this. Right side downward means it is positive. Therefore it is positive. Over. A and B points are over. We will draw shear force diagram for that. Okay. This is a point A, B, and this is a point A. At this point 0. At this point, sorry, not negative. At this point positive WL. At this point positive W into L. Okay, what is that? How to join this one? Straight line or parabola? That I have to see. Now here, what is that? UDL is there. I am drawing shear force diagram. Whenever I am dealing with the UDL, then shear force variation is linear variation or inclined variation or triangular variation. Therefore, here this will be linear variation. Okay, positive. This is SFD. Over. Now we'll come to bending moment diagram. Bending moment diagram is BM. At B I can consider bending moment at B. Bending moment at B, then section will be here. Then observations will make right side. When you make observations right side, what you are seeing? You are seeing nothing. Therefore 0. Over. Then bending moment at A I will see. At A means this is a A point. Then at A, where you want to observe? The observations I will make right side. Right side what you are seeing? Yes, I am seeing one vertical force and its distance is there. That's why moment will come there. The moment is this force WL into perpendicular distance is L by 2. Therefore WL into L by 2. Okay. This moment is causing in this direction. This is matching with this direction. Therefore it is negative. Minus over. This you can write it minus WL square by 2 over. Now I'll take one point here A and another point B, then join a reference horizontal line. Then here 0 it is given. Here it is minus WL square by 2. This is the point. How to join? Whether straight line or parabola. For that I will see here. This is a UDL. UDL given variation is parabolic variation for bending moment. Therefore, I will draw here parabola. This is the parabola. This is a negative bending moment diagram. Over. Right? We'll go to the next problem. The next problem is cantilever carrying UVL, uniformly varying load. with maximum load intensity at a fixed end and 0 at a free end. Okay, we'll draw first diagram. Okay, we'll draw first diagram. The diagram look like this. Okay, first fixed end, you have a maximum intensity. This is your UVL. This is your UVL, and this one is W. W is a small w. Then first draw free body diagram. Free body diagram, convert this UL into point load. That UL is converted into point load with the dotted load, because this conversion is for me, not given in the problem. This is area of the this UVL is your point load, half into W into L. That is your point load converted. Then this distance is the total is L, then this distance is L by 3, then this distance is 2L by 3 over, right? We'll mark this point as a and this point as a B. Now we will draw shear force diagram. Okay, first one, shear force at B. Directly I can consider at B. Okay, this is at B. Then observations, I will make right side. Right side, what you are seeing? You are seeing nothing. Therefore, over. Then shear force at A. Shear force at A means at this point. Okay. At that point, but observations you will make right side. Observations will make right side. Right side, what you are seeing? Right side, you are seeing one vertical force. Yes, that vertical force is half into WL. Very good. This half into WL is a vertical force, but the direction here it is matching with this one, right side downward direction. Therefore, it is a positive value. Over. Now we'll draw shear force diagram. Okay, we'll draw shear force diagram. This is horizontal reference line. At B point, it is 0. At A point, positive WL by 2. This is WL by 2, positive. How to join this one? For that I have to see our previous lecture. In previous lecture it is said, now which load it is? UVL. I am dealing with UVL. This is UVL. UVL I am dealing shear force, therefore parabolic variation. Parabolic variation means here I have to join it like this. This is parabolic variation. Right? This is positive shear force diagram, SFD. Okay. Now coming to BMD. Coming to BMD. Okay. First point, bending moment at B. Okay. Observations where you want to make. Observations right side. At this point, right side you are seeing nothing. Therefore, 0. Then bending moment at A. Okay. At A means stand at this point. Now observe right side. Okay, what you are seeing? You are seeing one vertical force, and this force is creating moment at this point A. Therefore, half into WL is a force, and that force is creating moment with a distance L by 3. Therefore, this answer is WL square by 6. But this is positive or negative. Now, this force is causing moment in this direction. That direction is meeting with this one. Therefore, it is negative. Therefore, it is minus. Over. Then I will draw shear bending moment diagram. This is 0. It is indicated here. Then at this point we have minus WL square by 2. Okay. Now variation. When you see the variation here, UVL is given, but bending moment you are dealing, that is cubic variation. Cubic variation roughly you can draw, because exactly you don't know. Cubic variation means it will be somewhat like this, and it will come. Okay. This is a cubic variation. Over. Right? Next we will go. Okay, this I will give you a homework. This diagram I will give you. Take it as a homework. What they say, cantilever beam maximum load intensity at the free end. This is a free end. the load intensity is like this. And at fixed and 0, okay, this is your load. Okay, you can send me the image of this SFD and BMD. You consider W and everything, you work out. This is A and this is B, this is L. Okay, you work out it. Next one is cantilever carrying UDL from fixed end to its midspan. Okay, to its midspan. Okay, this much means this must be L by 2 because midspan, and this must be L by 2. Right? Now you can consider point A. This is point A, this is point B, this is point C. You work it out. Okay, I will give you a diagram, then you can work it out. At this point shear force is 0, at this point shear force is 0, at this point shear force is there. Okay, how much is there? For that you have to convert this one into point load or dotted point load. This dotted point load is, this is W, therefore W into L by 2. This is W into L by 2. This is W into L by 2. And variation is straight variation. This is SFD. Okay, you write it down here. Those are points. Next, bending moment at this point 0, at this point 0, at this point WL by 2 into, this is L by 4. L by 4. Therefore, bending moment is WL by 2 is the load into L by 4. Therefore, WL square by 8 at this point, and that is my negative. Okay, you will write it like this. This is minus WL square by 8. Right? You write these all points in the right side. Okay, the last one. Cantilever carrying UDL from free end to its midspan. Okay, free end to midspan, this is very important. Now look at here. I will not write the right side of points, just I will indicate, show you. Now free end to midspan means this is your UDL. Okay, and UDL name is W. This distance is L by 2 because midspan, and this distance is L by 2 midspan. Right? Now convert this UDL into point load. That converted point line shown in dotted line. This is W into L by 2. It is W into L by 2. Okay, where it is acting? It is acting L by 2 from the L by 4 from this end, and from this end also L by 4. Okay, now shear force diagram. Shear force at we will name them. Okay, this is a point, this is a B point, and this is a C point. Now shear force at C point. Okay, observation, make it right side 0. Then second one, shear force at B point. B point means this one. Observation, you make it right side. Right side you are seeing one vertical force, that is WL by 2, and which is right side downward, therefore it is positive. Then shear force at A point. At A point. That A point you are seeing, at A point you are seeing W right side. You are seeing, observing right side. Therefore, right side you are seeing again one force WL by 2. Okay, na? This is also positive. Over, shear force is over. Then bending moment. When you write bending moment at C point. Bending moment at C point. Observe right side 0. Then bending moment at B point. Bending moment at B point here. Then observe right side. What you see right side? Right side you are seeing one load WL by 2, and that load is creating some moment at B point with a distance L by 4. That is L by 4. And this is hogging, matching with this diagram, therefore it is minus. Answer is minus WL square by 8. Where it is? At B point. Now come to C point. Bending moment at C point. Bending moment, sorry, at A point. Bending moment at A point, observe right side. What you are seeing in the right side? You are seeing this load. Right? Okay, you are seeing this load, and this load is creating a, what is this distance? This distance is, this is already L by 4 and this is L by 2. This is L by 2 plus L by 4. What is this L by 2 plus L by 4? That we will write it. WL by 2 is a load into L by 2 plus L by 4. This is L by 2 means 0.5, this is 0.25, 0.75 is a 3 by 4. This is 3/4 of L. Right? Now, this is a negative because hogging. The answer is 3WL square by 8. Now you will get that one. Now we will draw shear force diagram and bending moment diagram for this case. Now at this point 0, 0. At B point WL by 2. This is WL by 2. At C point WL by 2. Okay. Now no load, shear force variation is straight. No load, it is inclined. Okay, this is shear force diagram. Positive, positive, SFD. Coming to bending moment diagram. Bending moment diagram at this point 0. At this point minus WL square by 8. This is WL square by 8 minus. Now at this point 3 times of WL square by 8 means something bigger. This is your 3 times of WL square by 8. Okay. Now how to join? Joining is very important. This is a UDL, therefore it is parabola, and no load, therefore straight line. Straight line and parabola is your negative bending moment. Right? These are all simple and standard beams we have solved, and in the next video we will see cantilever beam only with some mixed loads, okay, which are given in assignment. Those things we will solve. Right. Thank you.